Hello dear children, in this class we are going to discuss the entire chapter of magnetism. Children, this chapter has two units. Mainly in a unit A, you will be learning about the types of magnets, induced magnetism, properties of magnetic field lines and neutral points. Whereas in a unit B, you will be learning about electromagnet, how and its applications and how does it differ from a permanent magnet. So children, if you can watch this entire video, I will give you assurance that maximum questions you can attempt, means correct answer. Attempting means not like attempting and leaving. Yes, you will be able to write maximum answers in a examination. Is it clear? Fine. So get ready with your pen and paper so that we will start without any delay. So children, one short video. Again, I am telling you all concepts without missing even one important point. Also, we are going to cover all concepts, all points, which will be very useful for your examination. Clear? Fine, children. So come to this magnetism actually, regarding this what we can say idea, this concept. So actually this magnetism, children, this concept was known almost before 2500 BC, means if you can count for this, almost 4500 years back these concepts were known. So children, mainly here this area called Magnesia. So it was noticed that in that Magnesia a kind of stones, so called lodestones and ore of iron oxide. So it was noticed that these materials, it was noticed that these materials possess a kind of properties, special properties. What are those properties, children? Yes, so these lodestones and ore of iron oxide, it was noticed that they are attracting the small piece of iron, and when these materials, when they are suspended freely, they are adjusting by themselves in a particular direction. This what we can, so the materials which possess these kind of properties only, we can call it as a natural magnets. Natural magnets. So why this magnet word is given? Because it was noticed in a Magnesia area. That's what the magnet name was given. So these are called actually natural magnets. But what are the drawbacks of this natural magnets? In examination they may ask you the question. So here these natural magnets are irregular or odd in shape, means as they are naturally occurring. So it's not some nobody made them actually. So that what will happen naturally, with irregular shapes only they are obtained. And here they are magnetically not strong, means they are a bit weak, we can say. Just they can attract small piece of iron, that's it, but you cannot use in what we can say wherever you want, because the strength is not enough actually. Okay, so what are the drawbacks of natural magnets? They are irregular and odd in shape, and their magnetic strength is weak. These 2 points are very important. Then how? You may get one out, sir. Then okay, they are weak, sir. Then how, if you want to use magnets in a certain place, we need magnets, so that we need a magnet with a strong magnetism, you may get out. So these are not useful. Then yes, these natural magnets are replaced with the artificial magnets. So what are artificial magnets? Yes, man-made magnets which we are making. The magnets which are made artificially are called artificial magnets. Then how these artificial magnets are better over a natural magnets, children? Quite opposite. Artificial magnets are regular in shape and they are magnetically strong. They are magnetically strong. Children, examination they may ask you to write the differences between natural magnets and artificial magnets. So again I repeat, artificial magnets are, they are regular in shape and their magnetic field strength is a very strong, means magnetically they are very strong, so that we can use in various applications. Okay, fine. So let us just talk about the artificial magnets. Let us see here. Artificial magnets. Artificial magnets. Children, in exam they are asking the differences. Okay, na? Differences between natural magnets and artificial magnets. So as I told you that these artificial magnets are regular in shape. They are regular in shape, perfect, and magnetically very strong. Magnetically very strong. Children, here again telling you, under artificial magnets only, we will be learning about permanent magnet, permanent magnets will come under artificial magnets, and here electromagnet also. Electromagnet also comes under this one. What is that? Electromagnet. Anyhow, these two types of magnets will be learning in a unit B. Of course, unit B means in the same video only. The same video only we are going to learn about the permanent. Means what I mean is that permanent magnets and electromagnets comes under artificial magnets only. So artificial magnets are regular in shape. They are magnetically strong. And example, children. Yes. So here example we have bar magnet. We have bar magnet, a rectangular bar magnet. So how it will be? So it will be like this. So either of side north and south will be there. And here second one is horseshoe magnet. Horseshoe magnet. So it will be in this shape, horseshoe magnet. So almost like this. Horseshoe magnet. It is north means this will be south. And here magnetic needle. Third one is what, children? Is a example, just I am talking about the magnetic needle. So magnetic needle. So here whatever is highlighted, children, so this is north pole, another one is south pole. Even magnetic compass also. So this is about the artificial magnets, and examples means you can write. Are you able to see? Let me check out. Fine. Now we see the properties of magnets. When I say properties of magnets, especially let just keep a bar magnet in your mind, so that what will happen, it will be very easy to us to catch it. Okay, catch the points. Okay, na? So here magnets and properties. Magnets and their properties. Okay, na? So first one, the very important. So what is that actually? It's a directive property, children. What is that? Directive property, which means what? If any bar magnet or a magnet, okay, no problem, magnet, when suspended freely by means of a silk thread, what happened? It comes to the rest by showing geographical north and south. So in exam they may ask you to draw this diagram also. Okay, what is the directive property, children? So when a bar magnet is suspended freely by means of a silk thread, it comes to the rest by showing geographical north and south. So where we can use this property, children? Yes, in order to make a compass. That is the reason. So if you want to go in a particular direction, so we will be holding a compass and we will be checking. Even during the construction of houses also, they will be checking regarding some vastu and all these things, right? Okay, so it's a directive property. And the second one is a pair property. What is the second? Pair property, which means what? For example, here is a bar magnet. Okay, it's a north pole and a south pole. If it is broken into two pieces, and what will happen? Yes, here we get two pieces, right? But here it is north only. The place where it is cut, children, there it obtained opposite pole. That is a north south. Here is south is there. Here north. Let us say it is again got broken. Then what happens? Here two pieces. Okay, here also two pieces. Here is a north south, which means what? Like this, children, you go on breaking till you get a one molecule. That particular molecule also possesses two poles actually, north and south only. Is it clear? Which means what? With this it's very clear that, children, very clear that, very important this is. So monopoles do not exist. Monopoles do not exist. Which means what? You cannot obtain only magnet with the one pole with a north pole or a south pole. It is not possible. So always magnet exists with the two poles only. That is a north and south. So this is a pair property. Okay. And third one, attractive property. What is that? It's a attractive property. So which means what here? the magnets can obtain some substances. Those are called magnetic substances. Very, very important. Very, very important. Magnetic substances. What are magnetic substances, children? The substances on which there is an impact of magnets are called magnetic substances. So these, whenever this magnetic substance is brought near the magnets, what will happen? They will get attracted as usual. Okay, na? Fine, children. Now here, and here, for example, what happens if here two North Pole and South Pole is there, two magnets here. So that is the North Pole and South Pole. Then what will happen? These are unlike poles. Then what will happen? These will get attracted. These will get attracted. Whereas if you can bring two like poles, north to south, south to north, then what will happen? These will get repelled each other. Which means what here? Like poles will repel each other and unlike poles will attract each other. Okay, children, fine. So these are the some important properties of magnets. Just note down for examination point of view, it's very important. Okay, done, fine. Now children, okay, let me just erase this. Then one very important concept which we are going to learn. 100% there will be a question in an exam if this chapter was there in your exam, if it is there. Okay, now so what is that here? Magnetic induction point of view, it's very important. So already just we learnt about the magnetic substances, children. What is that? It's a magnetic substances. What are magnetic substances? The substances on which there is impact of magnets. Mostly it's if you can talk about the iron kind of materials, they are attracted by the magnets. So we are very familiar with that, right? Okay, fine. So first we learn what is a magnetic induction, why it is happening, what as a result of magnetic induction, what will happen, why these materials so-called material like iron, why they are attracted, why they are not repelled. Okay, for suppose children, let us take here the one bar magnet. Let us take bar magnet. Let us say either of it is a south or north or south. It's not a problem at all. You can just, okay, fine. And here, if near to this one iron piece is placed nearer to it, I'm talking near to it, then what will happen? Yes, we all know very well that here this iron will be attracted towards the magnet. It's very clear. Okay, fine. So means it will go near to it, means it will get attracted. I can say like this, it will go here. Now the important thing is that, for suppose near to this iron, if I can bring one iron nail, children, iron nail, if I put, what will happen? This iron nail also will be attracted by this iron. Try to understand. Okay, if I put one more nail, yes, it will be attracted. If I put one more nail, it will be attracted. If I place one more, it will attract it. Depends. You may get a doubt, sir, how many nails can we place? It depends on this what we get the strength of the magnet. If the strength of the magnet is more than that of the weight, that is a force of gravity which is acting on these nails, then what will happen? They are attracted. If this this weight is more than magnetic strength, then they will fall. So like this, we can make a big chain of nails. But children, the moment when this one iron is removed in this chain, then what will happen? Do you think that still these iron nails will be attracted as like in the form of chain only? No, they will fall down. What is the reason? Means here, it is not whatever, it is attracted. Means what is happening? It is a temporary situation. Just as a temporary phenomena, it is not a permanent phenomena. So during this, what is happening? So let us take a small example, children. For example, here two boys are there, or two students, might be boy or girl, is not a matter. Two students are there. Let us say the student A is eating ice cream. Let us say is eating a ice cream. In general case, some exceptional case, I don't know. In a maximum, in most of the cases, what will happen? Just you think that these two are sitting just side by side. If the student A is eating ice cream, obviously, children, don't you think that after some time the student B also feel like eating ice cream? He may not tell, but definitely the thoughts are induced. The thoughts are induced means he is not getting the thoughts on his own actually. Because this student A, the thoughts are induced in a student B mind actually. But how long those thoughts will be there? As long as the person B is sitting with the A or till it completes. The moment when this ice cream finished, or the person student B will go means far from this person A, student A, then what will happen? The thoughts may not be there. Doing that, those thoughts are permanent, lifelong. The student B will have I should eat ice cream, I should not that. It's a temporary. It's a temporary thing. It is happening. So now just compare with this situation here. It's like a it is like a B. So here what is happening? Because this magnetic substance is placed near or in contact with the magnet, then what is happening? Some magnetic properties are induced in iron. Try to understand. So why we'll discuss later. Just why, what is the reason means we'll discuss next. Don't worry about it. Just for the sake of understanding. So just try to understand here, children here. So when this bar, what we can say, it's a piece of iron is placed near or in contact with the bar magnet, what is happening? Temporarily some magnetic properties are induced in a iron. Then what is happening? It is feeling like, yes, I am magnet. As it is feeling like a magnet, as it is getting a magnetic property, it doesn't know that it's a temporary. So it knows that yes, now some magnetic properties are induced in me, so I am like a magnet. You feel that yes, I am magnet. As it is feeling that it is a magnet, obviously it will attract all magnetic substances. But the moment when this iron is removed, kept far from the magnet, then what will happen? The magnetic properties are lost. Then it behaves like a normal iron. As it is behaving like normal iron, do you think that all these are attracted? Obviously no. Clear? So this phenomena only we can call it as a magnetic induction. Children here, magnetic induction, it is a temporary only, very important. So temporary. It is a temporary only, very temporary thing it is. So magnetic induction is a temporary phenomenon, due to which what will happen, any magnetic substance is placed near or what we can say in contact with the bar magnet, possesses what will happen, some magnetic properties in it temporarily. So this phenomenon only we can call as a magnetic induction or induced magnetism. Children, here a few important points we need to understand. So what is that here? The important point which we need to understand is that, first of all, why it is attracting, what is happening here, let me tell you here. So especially children, it is south pole and here is north pole. Whenever this iron bar is placed near to it, please try to understand, means here near this north pole, so this end is there. So at this end, children, the opposite polarity is induced. As here is north, means here south is induced, and other end similar polarity is induced, let us say north. As opposite polarity is induced, then what will happen? This will get attracted towards the magnet. Is it clear? Which means what here? Magnetic induction precedes, very important children. Magnetic induction precedes attraction. Why magnetic substance are attracted? Because near the end of any pole, either north means south will be induced, south means north will be induced. So opposite polarity is induced. So that what will happen? They will get attracted. Which means what? Magnetic induction precedes attraction. Okay, fine. So examination point of view, how the questions can be asked. Can I remove this? Okay, fine. Now look at this one important point. So how the questions can be asked based on this topic. For suppose children, and here south is taken. For suppose children, here two iron nails if you will bring near to the magnet, yes, due to the magnetic induction they are attracted. We know very well. Okay, let us say that it is one iron nail. It is one iron nail, and here also let us say one more iron nail is there. This will be one more iron nail is there. What is the reason? Just because of magnetic induction. But during this magnetic induction, what will happen, children? So near the end of the magnet, in magnetic substance, opposite polarity is induced. That is the reason why they are attracted. That is what actually we have learnt in this magnetic induction. Okay, now children, as per that concept, here north means this should be south, this head of the this one, yes, sorry, south, right? South, it is south. This also south. As it is south meant this end, that is the end of this, the tip of the nail, it should be north. Here south means here north. But children, do you think that, don't you think that these two are the similar poles, like poles? But we learned under the properties of magnet, like poles will get repelled each other. So the moment when you bring near this magnet, first they are attracted, later these tips will get repelled. These tips will get repelled. So finally how the diagram will be, look at here. Finally the diagram will be like this. So very important. So this will be like this. Okay, and this end will be like this. This is how they will become. So this is south, north, south, north. Is that clear? Fine. And here also, children, it is north means, so near the end of this north pole, in this nail, south pole is produced, generated. South means here, north is generated. Children, head of the nail is south means tail will be north. Head of the tail will, what we can say, nail will be north, means this will be south. Now, don't know these two are unlike poles? Yes, but unlike poles will get attracted. So what will happen, So this will become like this. Let me just, I'm erasing this, okay. So finally, how they'll become, so like this will become. So this is how, let us say it's a nail. So they'll get attracted. This is nail, they'll get, wait, let me draw properly. So like this, so it is a south, it is a north, it is a north, it is a south. So based on this, children, definitely we can expect the question. So if you are referring the textbook, just kindly look into the example question answers. So there, I think these examples should be discussed there because they are very important. So in exam, if they want to give application questions based on the magnetic induction or induced magnetism, so these questions must be given. Is it clear? Fine. So this is what actually magnetic induction. Clear? Fine. Okay. Now come to this. Here you may get one question. Okay, sir, north pole is induced, south pole induced, all these things are happening. But what is the reason? So if you want to understand that reason, children, so you should understand magnetic field. Magnetic field is a vector quantity. Very important. Magnetic field is a vector quantity. So we know that near any magnet, if you can put a magnetic substance, they'll get attracted. But what is the reason? Means reason is a magnetic field. Then what is a magnetic field? Yes. So look at here, children. For suppose here is a bar magnet. Let us take a bar magnet. You can take any magnet just for sake of convenience. Just we are taking a bar magnet. It is not that you should always take a bar magnet. It's not mandatory. Okay, fine. So here, let us say it is a north and it is south. Children, so around this, so the space around this magnet, children, means three-dimensional space you can imagine. For example, here is a bar magnet. Okay, now, so three-dimensionally, so the space around the bar magnet, in which, for example, if you are putting other magnetic pole, either north or south, you are bringing north or south, then what will happen, the space around the bar magnet in which magnetic pole experiences some force. It might be attractive force or repulsive force. For example, so north means it will experience attractive force. If you are bringing a magnet with a south pole, then we will get a repulsive force. That space around the bar magnet, in which a magnetic pole experiences some force. Force means it might be attractive or repulsive. That space only we can call it as a magnetic field. Clear? Fine. So it is not, it's visible. It is not visible. Children, then what will be there in this magnetic field? Children, this magnetic field is consisting of what? Consisting of magnetic field lines. That's fine. Okay, we'll learn separately about the magnetic field lines. Don't worry about it. But mathematically, how can we define a magnetic field? For example, we are bringing either north pole or south pole. Okay, it's not like a, at the same time we are bringing two poles. See, as you are bringing one magnet towards a magnet means either you are bringing south pole or north pole. So monopole, I can say that. Okay, now, so that only we can use pole, or we can say pole, it is magnetic pole. So this magnetic pole, children, so where means polarity, that will represent with a small letter m, magnetic pole. Okay, na? So here m means might be north or might be south it is. So what will happen, there will be some force acting on this pole of the magnet. So the force acting on unit magnetic pole is called magnetic field. Very important. Very means very much. See how much force is acting on a unit magnetic pole. You may get one doubt, sir. You only said that unit magnetic force force won't exist. Yes, won't exist. What I mean to say that I am bringing our magnet means, so this see this is north, let us say south. So I am bringing north pole, right? So how much force that north pole is it's experienced, that force in that magnetic field. I mean that can be written in terms of B actually. That is how B is equal to F by M. So here SI units, very important, children. So force is measured in Newton. Okay, na? So this is pole strength. Pole strength units are ampere meter. So in a, it's not SI system actually. It is in terms of force and length. So what is the SI unit of magnetic field, children? Tesla. So Tesla is a, what we can say, SI unit of the magnetic field, whereas CGS units are Gauss. Gauss, Gauss. So here 1 Tesla is equal to 10 power 4 Gauss. 10 power 4 Gauss. These are very important for an examination point of view. Just copy this. Now as I told you that in a magnetic field, what will be there, children? Magnetic field lines will be there. Now we will see the what is a magnetic field line and what are the properties. Now look at here. Here is, let us say, it is a north pole and a south pole. Let us say some space. So around this, that is so called magnetic field. Magnetic field. For suppose, children, for suppose here one north pole is placed. What is that? North pole is placed. Again you may get wondered, sir, how it is possible? Just assumption. In a magnetic field, for example, if it won't exist at all, it's a purely our assumption only. Please try to understand. Assumption only, or imagination, let us say that. Assumption, not imagination, it's assumption it is. So for example, if it would exist, it won't exist only. If it would exist, so I am putting a north pole in this magnetic field. Then what will happen, this north pole would go along a particular line. See, definitely it will be repelled by this north. So it is repelled by this north and it is attracted by this. So then what will happen? It would go along a particular path. Okay. Now, this path, the magnetic field means in a magnetic field, the path along which magnetic north pole would move, if it would exist, it would move. That path only we can call it as a magnetic field line. I repeat once again. The path in a magnetic field, the path along which a mono north pole would move, that line only we can call it as a magnetic field line. Children, so purely it is a imaginary lines. Magnetic field lines are imaginary lines. There is no physical we cannot see that. Okay, then how can we identify? Yes, in a lab we can do a small experiment. What is that? Near a bar magnet, if you can just sprinkle some iron filings, if you can just tap that, a paper, what will happen? They'll get adjusted, right? So I'll try to show here. Just you can look into it, and it is already uploaded in our shorts also. Okay, no? So fine. So this is all about magnetic fields. Okay, so we can, with the help of iron filings only, we can see that. Okay, fine. So here, then what are the properties of magnetic field lines? So first one, children, as I told that they are imaginary lines. They are imaginary lines. And children, externally, very important. Externally, that is externally. Let me just make a little bit big one so that to have a clarity. So it is is a north. It is a, this side is a north, this is a south. So external, what will happen, you know, they will move from like this, north to south. It's very, 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 very important. They are going like this. They are going from north to south. So they are going north to south. North to south. So externally, they will move from north to south. Whereas internally, children, internally, they will move from south to north. So here to here they are going. So then what will happen, you know? So they are again south to north. So this is also south to north. So here also south to north. So here also south to north. So look at here. Externally they are going from north to south, but internally south to north. Means look at here, tring like this. So can I say that they are like loops? Yes, 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 they are looped, right? What is the starting point? What is the ending point? We cannot define actually. We can't define. That's what we can say, that for a magnet, there is no source and there is no sink. We cannot say that where they are starting and where they are ending. External, they are from north to south, but internal again south to north only. Is that clear? Fine, children. So the third point, they are closed and continuous curves. They are closed and continuous curves. Continuous curves. That's fine. So as I told you that, children, here magnetic field is a vector quantity. Then how to identify the direction, how to find the direction of magnetic field, children? For example, at this point, if you want to know the, at this point A, if you want to know the direction of the magnetic field, there just draw a tangent. This is a tangent. Okay. Here if you want, let's say it's a point C. So here you make a tangent. It gives you direction of magnetic field, which means what here? The tangent drawn at any point on field line gives direction of magnetic field, but at that point only. Clear? Fine. And the last very important thing is that here examination point is very important. Separately it can be asked. What is that? No two magnetic field lines, no two magnetic field lines can intersect. Means magnetic field lines can never intersect. In exam they ask a question, why? So statement given me like this: no two magnetic field lines can intersect. Give a reason, explain. Separately it can be asked. Or else, can two magnetic field lines can intersect? Give a reason. Okay, fine, children. Let us try to understand here. Separately we need to discuss this point. So here the thing is that we take a wrong assumption and we prove that the assumption is wrong. Don't get confused. Again I repeat. So we just take one wrong assumption. We prove that assumption is wrong. So what is that assumption? We assume that two magnetic field lines can intersect. So it's assumption. We will assume that magnetic field lines can intersect, and we prove that statement is wrong, which means what? They cannot intersect. Okay, now fine, children. So for suppose, let us say here is one magnetic field line, let us say P. Okay, now, and here is one more magnetic field line, let us say Q. So it's assumption, children. Again I'm telling you, it is purely assumption. Purely it is a assumption. So we are assuming that these two field lines are meeting. Where? At this point. At this point O. But now if I want to know the direction of magnetic field at that point O, children, how to find the direction of magnetic field at a given point on the field line? We have to draw tangent. Okay. For this Q magnetic field lines at this point P, it will be in this direction. Okay, magnetic field lines. With respect to this field line P, the magnetic field lines field will be like in this direction. Means let us say it is a B1, is a B2. But my point is that At this point, see, magnetic field is a vector quantity. So, any vector can have only one direction, right? But at the point O, what the direction of magnetic field? Either it should be in this direction it is possible, in this direction it is possible. Means as per this assumption. But is it possible to any vector to have two directions? No, it is highly impossible. So this assumption itself is wrong. Which means what? They do not intersect. If they would intersect, at the point of intersection, there would be two directions. It is highly impossible. Hence, they do not intersect. Here, at this point, for example, a magnetic compass is placed. A magnetic compass is placed, let us say, magnetic compass. What would happen? If you can keep a magnetic compass near any magnet, it has to adjust it at a particular direction. But here means the magnetic compass will be there towards B1, B2, B1, B2, B1, it is getting confused, right? It shows neither towards B or nor towards B1 or B2. It's not possible. It won't in a particular direction only. So this is completely wrong. So which means what? No two magnetic field lines can intersect. Okay. So this is all about the magnetic field and the properties of magnetic field lines. Clear? Fine, children. Now, before going to talk about the earth magnetic field, we need to learn about the types of magnetic fields, children. Types of magnetic field. So first one is a uniform magnetic field. Uniform magnetic field. Uniform magnetic field. So what is a uniform magnetic field? What is uniform magnetic field, children? So look at here. In a given, look at here. Let us say the field line. So here, this is the best example for just I am drawing to make it to understand. Means what? In a uniform magnetic field line, children, the space between the field lines is a unique. Mean they are equidistant. They are equidistant. First point, they are equidistant. Field lines are equidistant. Field lines are equidistant. Equidistant. And here at every point, field strength is same. At every point, field strength is same. Field strength is same. Is it clear? Fine. So now non-uniform magnetic field. Non-uniform magnetic field, children. So quite opposite. Quite opposite. So the magnetic field in which the magnetic field lines are not equidistant. They are not equidistant. So for example, let us take a bar magnet. The magnetic field around the bar magnet only. Let us say the north and south. So the field will be like this, right? The field will be like this. So look at here. So let us take here. Let us take here. So do you think that they are equidistant, children? No, they are not equidistant. The field lines are not equidistant. So that what will happen? Here field strength is more near the poles. Here field strength is less. So such a magnetic field is called non-uniform magnetic field. Clear? Fine, children. So now we discuss the magnetic field for what actually? Magnetic field due to what, children? Magnetic field due to earth. So magnetic field of earth. Okay, erase this. Fine. So in exam, they may ask you what are the evidences. So how can you say that? Okay, na? So how can you say that there is a magnetic field around the earth? Earth magnetic field. Earth magnetic field. Field around magnetic field. Children, and one more very important thing is that, children, here, for example, it is a magnet actually existing. Don't worry. Around the earth, magnetic field existing, children. So this magnetic field is protecting us from many radiations which are coming from the outer space actually. So they do not enter into the atmosphere. Why? Because as these are charged particles are coming into the earth's surface, they are repelled by this magnetic field. So we must be very thankful to this magnetic field. Otherwise, you know what will happen? So all dangerous radiations would enter into the earth atmosphere, which causes so many diseases and dangerous things that are very, very harmful to us. Clear? Fine. Then what are the evidences, children? First evidence, children. First one. If you can take a bar magnet, if it is suspended freely, what will happen? Any magnet you can take. So that particular magnet can adjust itself in a particular direction. That is north and south. Why it is setting along the north and south? Yes, because Earth has a magnetic field and is showing impact on the magnet, and the Earth is making the magnet to adjust in a particular direction. Okay, fine. The second one, children. So if any very huge long iron bar is buried in the earth along the north south direction, after few days or after few months, it becomes like a magnet. Why it is becoming like a magnet? Because earth is a magnet and this bar magnet is placed within the field of the earth. So then what will happen? That earth magnetic field showing the impact on this iron bar, so that it is becoming like a magnet. Okay, fine. And the third one, children. Yes, neutral points are existing. You may get a wonder, sir, what are neutral points? We'll discuss, don't worry. Neutral points around the bar, around the magnet, there will be two neutral points which are existing. So these are the evidences, children. These are the evidences to say that yes, there is a magnetic field around the earth. Children, in examination point of view, as I told you that here, a uniform magnetic field in a given small region, children. So they may ask you to draw the magnetic field of the earth, children. Magnetic field of the earth. So magnetic field of the earth, how it will be there? In a given small region I am talking. In a small region, how the magnetic field due to the earth will be there. So it will be like this. So it will be like this. Very important it is. So in exam, diagram might be given, they may ask you a question, or else they may ask you to draw the magnetic field due to the earth. So this is from south to north. South to north. So can I say that the uniform magnetic field? Yes. So in a small region, in a small space, children, so the magnetic field on the bar magnet is a uniform magnetic field. So what is direction? It is always from south to north. Clear? Just copy it. Now we'll discuss the neutral points. So this is how actually magnetic field will be there. Children, here we have two cases. Try to understand. Here is a case 1. Here is a case 2. First, identify the direction here. Identify the difference, children. Here, magnetic north pole is pointing out the geographical north pole. But whereas here, magnetic south pole is towards the geographical north pole. That is the difference we need to identify. So if you can place a bar magnet in these positions, first case north, magnetic north should be geographical north. In the second case, magnetic south towards the geographical north. Then what will happen? You will get like this magnetic field in experimental if you can do it. Actually, you will find that there are 2 points here, where there is no magnetic field, which means what? Magnetic field strength will be 0, and here also magnetic field strength will be 0. Let us say it is a N1 and N2. And in this case, so here you will find points, so where magnetic field strength will be 0, and here also magnetic field strength will be 0. Let us say this is N1 and it's N2. So here these 2 points, in this case these 2 points are called actually neutral points. Children, in exam they may ask a question. Where the neutral points will be lying if magnetic north pole is pointing out the geographical north pole? You should write that neutral points are lying on east, what we can say east west. Along the east west they are, what we can say, they are placed. Okay, fine. And here if magnetic south pole is pointing out the geographical north pole, then in which direction they are, identify where these neutral points are lying. They are lying along the north south, here north south, here east west. Okay, fine. First, again you may get on doubt, sir, okay, it's everything is fine, but what actually neutral points? Children, magnetic field is a vector quantity. Let me give you an example. For suppose it is a point, this point, in this direction, for example, 10 Newton force acting, and in this direction 10 Newton force acting, for suppose. Okay, then what is the net force at this point, children? Yes, at this point is a 0. At this point 0. Okay, similar to it, children, here we have already we know that around the earth magnetic field will be there. Around the bar magnet, magnetic field will be there. Am I clear? So let us say it is a bar magnet. Around this magnetic field will be there. Don't you think that around means near to it somewhere here also earth magnetic field will be there? Yes. Means here what is happening? The magnetic field due to the bar magnet is interacting with the magnetic field of the earth here. Means for suppose around this bar magnet, let us say at this point only. Here what is happening? So there will be a point near the bar magnet where magnetic field due to the bar magnet is equal in a magnitude and opposite to the magnetic field due to the earth. Magnetic field due to the earth. Let us say it is 10 Tesla and here is a 10 Tesla. So at this point, these two magnetic fields are equal in magnitude but opposite direction. Then at this point, what is the net magnetic field? Net magnetic field is 0. Such a point only we can call it a neutral point. So at a neutral point, children, what is the magnetic field strength? 0. At a neutral point, magnetic field strength will be 0. It's very, very, very important. Magnetic field strength will be 0. Am I clear? Fine. So what will happen if magnetic compass is placed at the neutral point? So see, generally when a magnetic compass is placed in a particular place where magnetic field is there, that will set into that particular direction of the field. But at a neutral point, there is no magnetic field only. The magnetic field strength is 0. So then what will happen? Magnetic field can show in any direction. Magnetic field can show in any direction. Don't worry, in exam they don't ask you to draw the diagram. Just only they'll ask about where this neutral points are lying when north of the magnet is pointing out towards geographical north, south of the magnet pointing out towards the geographical north. Is it clear? Just copy this. We discuss about now electromagnet. Electromagnet. Children, before going to learn about the electromagnet, we need to understand about one word, very important, physical quantity. Let us say, what is that here? Retentivity. Retentivity. What is that? Retentivity. So, if you can understand this retentivity, then you will understand the difference between permanent magnet and electromagnet. Why particular material must be used. So, we know that soft iron is used to make an electromagnet and steel is used to make a permanent magnet. But why they are used? So, if you want to that, actually first you should understand what is the retentivity, children. So, it is the ability to retain. Very, very important. What is the retentivity? The ability to retain. So, this is a combination of two words. I can say that. Ability plus retain. Ability plus retain. Ability to retain, which means what? As see, already we learned about the magnetic induction, children. So whenever a bar magnet is whenever a magnetic substance is placed near the bar magnet, it gets attracted. Why? Because around the bar magnet, what will be there? Magnetic field lines will be there. That magnetic field lines will pass through the iron piece. For some time, means as long as the magnetic field lines are passing through the iron piece, it behaves like a magnet. It behaves like a magnet. The moment when you can remove this, what we can say, bar magnet, then what will happen? No more field lines through the bar, what we can say, iron bar. Then what will happen? It loses its magnetic properties. Means this retentivity will tell you how long a particular magnetic substance will retain magnetic properties in it. For example, here two substances, X, it is Y. So these two magnetic substances are placed in a same magnetic field. Let us say 2 hours. 2 hours. Let us say both X material and Y both are placed at 2 hours in some magnetic field. After 2 hours, the magnet is removed. The X magnet is removed. Then we notice that this X is behaving like a normal material only. But Y still it is behaving like a magnet. Still it is behaving after 2 hours. When you remove that extra magnetic field also, it is behaving like a magnet, which means what? It is carrying some magnetic properties in it, but it is not that. So it has an ability. So now I can say that this Y substance has more retentivity, X substance has less retentivity. So the material with more retentivity will carry the magnetic properties for a long period, whereas the material with less retentivity will carry the magnetic properties temporarily. As long as external field is there, it behaves like a magnet. The moment it is removed, it behaves like a normal material only. Is it clear? Now with this knowledge, we will go ahead with the electromagnet. First, what is electromagnet? First point, electromagnet is a artificial magnet. As I told you, there is a artificial man-made. It is artificial one, and it is a temporary. One word you need to understand individually. Temporary, and it is a very strong magnet. And it is made up of with a soft iron. It is made up of with a soft iron, children. Made up of with soft iron. So why we are calling it the artificial magnets? Because we are making it. Why temporary? So if you want to understand why temporary, with what it is made up of with a soft iron. Why it is made up with the soft iron? Because soft iron has less retentivity. That is what I am telling you. Less retentivity means soft iron loses the magnetic properties easily. Clear? Fine, children. So now how it is made? Look at here. How it is made. Children, this diagram is a very important examination point of view. A diagram based question will be there. So for suppose let us say here is a rheostat. Children, this is called actually I-shaped electromagnet. Here we see, as I told you, the artificial magnet, it is in our hand. Whether whatever the shape you want, you can make it. But as per the syllabus, we have I-shaped magnet and U-shaped magnet. That is so-called heart-shaped magnets. So let us discuss mainly examination point. It's very important. Even I will try to show you that U-shaped magnet also. Okay, fine. So children, look at here. For example, here it is AB is a soft iron core. Children, AB is what here? Soft iron core on which insulated copper wire is wound. Insulated copper wire is wound. You make it on dot. Sir, why did you draw two diagrams? Okay, I'll tell you why. Just it was. Wait. You will understand why it is made like this. Why two diagrams are needed? I'll tell you. Fine, children. So yes. So now here is switch is on, children. So current always flows from positive to negative. So this is how current will be flowing. Right, now very this is the direction. Children, now what happened? As long as the current is flowing through the coil. So children, in a 10th class you will be learning about INDUCED experiment. What is that? So INDUCED experiment proved that whenever current passes through a wire, what will happen? It behaves like a magnet. Means around that magnetic field will be there. Now through this coil, as the current is passing, it behaves like a magnet. And where this soft iron core is placed, children? It is placed in that magnetic field, right? So what will happen? As it is in magnetic field, some magnetic field lines will pass through the soft iron core. Then what will happen? Some magnetic properties are induced in the soft iron and it behaves like a magnet. The moment when I switch off this current, what happens? There is no magnetic field around this coil and soft iron has a less retentivity. It loses the properties easily. That is the reason why are we using this soft iron core, because it has less retentivity. Okay, now let us think that yes, current is passing. Children, as long as the current passes, this soft iron core also behaves like a magnet only. So as soft iron core is behaving like a magnet, children, so there must be two polarities. In exam they will ask a question. So identify the polarity, whether A is south, B is south, A is north, B is north. How to identify? For that we have a clock rule. So before that, at the two ends, we have to know that the direction of current, whether it is a clockwise direction or anti-clockwise direction. Once you can identify that, you can identify whether given is south pole or north pole. Other is too difficult. For suppose children, here at the end, how the current is entering. Children, you imagine from here, just you try to look this. So here, so at this point, current is coming like this. Try to understand in this direction, which means what? Current is a clockwise here. So here, current direction is clockwise. So here clockwise means obviously come this side. So here current is coming like this, right? For current is coming like this. So which means what? Here it is anti-clockwise. Try to understand. So clockwise and anti-clockwise. So I will give you hint as per the clock rule, children. Here as per the clock rule here, the very important thing is that look at here, children. So here is, let me try to make a little bit big. So here is, okay, just take two circles, okay, now fine. And here is how the current is flowing in this first case. Let us take a clockwise current. Okay, now here is clockwise current. Okay, and here it is anti-clockwise direction, anti-clockwise. So this is here anti-clockwise. So look at here. Okay, fine. See, you are saying, sir, what is happening? Why are you drawing all these things? So look at here, children. Now, so yes, let me erase this part. Yes. Now here, let me erase this part. Yes. Children, can you feel in letters here? Yes, it is south and here is north. S, N. S represents south. N represents north. So here, in which direction the current is flowing, children? Here, clockwise. So the end of the coil, if the current is flowing clockwise direction, that takes south polarity. At the other end, if the current is flowing in anti-clockwise direction, it takes a north polarity. That is actually our idea to identify. Now here is a clockwise, right? So at this end behaves like a south, takes south polarity, and this take a north polarity. That is fine. But children, it is not compulsory that always left is south, right is north. Please don't remember like that. You have to check the terminals of the battery. Here plus means current is flowing. See, that's what here I made second one. Children, please, here the second one, can you just pause the video? Can you tell whether A will take a south polarity or north polarity? Come on, pause the video and just think and just comment your answer. So if you can comment, just means if you are getting means, which means what? Yes, you are able to follow the concept. Come on, 3, 2, 1. Okay, fine. Now, children, hope you have commented your answer. Yes or no? Yes, you have to do it. Fine. So here plus or minus means current direction will be now like this. Current direction will be like this because positive to negative, right? So it is current direction will be like this. Yes. Now at the end A, current is coming like this. Current anti-clockwise here. Current is anti-clockwise. Current is anti-clockwise. But here at the end of B, current is entering like this. Current is entering like this. So here is a clockwise. Here is a clockwise. So which means what here? This is now here. This B acts like a south one. This A takes now it's a north pole. Okay, na? So it depends, the polarity of the electromagnet depends on the direction of current. This is even one of the important advantages also. Okay, so this is about the electromagnet. In exam they will ask you how these electromagnets are better over a permanent magnets. And before that, children, as I told you, that is a strong magnet. How can you make a strong electromagnet? So or else in exam they will ask you a question, how can you increase the strength of the electromagnet, children? There are two ways. Please note down. There are two ways to increase the strength of the electromagnet. What is the first one? By increasing the number of turns of the coil. I repeat once. How can we increase the strength of the electromagnet? By increasing the number of turns of the coil. Clear? Fine. Now, what is the second ways? What is the second method? Yes, here rheostat is there. What is the purpose of rheostat? We can change the amount of current in the circuit, in the coil. So by increasing the amount of current, we also can increase the strength of the electromagnet. Clear? Fine. And when it comes to the permanent magnet, children, very important, permanent magnet. So what is that second one? Permanent magnet. In exam they may ask you to write the difference also even. Permanent magnet, children. I think a video might go more than 1 hour. 1 hour 15 minutes. Just I am expecting, I don't know. But let us see. Because we are not missing points actually. Maximum points we are trying to cover so that you should get benefited. Okay, fine. Let me have some water. Yeah. Fine. So children, permanent magnets are made up of with steel. Why they are made up of with steel, children? Why they are made up of the steel? Because the retentivity is very high. The retentivity is high, children. Means once they are get magnetized, they do not lose the magnetic properties. Okay, so in exam they ask two questions. With what material permanent magnets are made? Yes, steel. Why steel is used? Because of high retentivity. Now, what are the differences between permanent magnet and electromagnet? Also very important. Children, permanent magnet, let us take it as a permanent magnet, say north and south. So for this permanent magnet, can you change the polarity? No, we can't change the polarity. But whereas for an electromagnet, we can change the polarity. How? By changing the direction of current. So for a permanent magnet, we can't change the polarity. For electromagnet, we can change the polarity. And the second difference here, for permanent magnet, children, we can't increase the strength. We can't increase strength. But whereas for electromagnet, we can increase the strength. There are two methods, by increasing the number of turns, by increasing the amount of current. Okay, na? So these are the differences between electromagnet and a permanent magnet. Just copy this diagram. Now the last point is the applications of an electromagnet. Plus, minus. Okay, fine children. So let us see the, are you able to see the diagram? Yes, fine. So applications of electromagnet, children, here. Applications of electromagnet. So here electromagnets are used to lift the heavy iron scrap. Yeah, here I will clarify one point actually. Sir, why a soft iron is used? Means I told you that because it has a low what we can say retentivity. But why low retentivity is needed actually? Why it should be temporary only? Means let me tell you. For example, children, you think that it is electric crane. You think my hand not electric crane. Just assume that it is a hand electric crane, and here electromagnet is there. Now let us think this iron is a big heavy what we can say big heavy one actually. Let us say this has to be shifted from one place to another place. Then this electromagnet is taken near this, over it is placed. Now current is on. The moment when current is on, what will happen? It behaves like a magnet, right? Electromagnet. So it is attracted. It is taken. Here I want to place this here. Now what will happen? Just now current is off, switch is off. Then what will happen? It is left. Hope you are understanding why it should be temporary only. Why are we using soft iron only? So this is actually the reason. For example, if you use a steel, what happens? It will be permanent magnet. Once it will take this iron log, it won't leave it only. Okay, fine. So it is used in lifting heavy iron. So that is the reason why it is also used to load the furnace with iron. So if you want to fill that furnace with big iron blocks, that has to be carried till there actually. And separating the iron pieces from debris. So whenever there is a scrap kind of debris will be there, where we have to separate iron ore and other things, there we use this. And even so whenever there is a problem, what we can say, yeah, separating the iron pieces from the debris, that's fine. And this is very important, electric bell. So it is also used in a telegraph and electric bell. So children, in exam they don't ask you to draw this diagram, don't get confused, don't get tensed, oh my god. So no need to practice, but based on this questions will be asked. So let us try to understand the function of the electric bell. So here some parts, main parts are there. It's a gong, it's a hammer. When this hammer will hit this gong, ting, 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 sound will come. But in a schools, can you hear ting, ting like this electric bell? No, like this it will be. Okay. So what kind of sound can you imagine? Can you recall the sound of the bell? Yes. Are you able to hear? Yes. Yes. Fine, children. So how it will just beat that gong continuously? What is the reason? So here is this is what actually is the electromagnet, U-shaped electromagnet. U-shaped electromagnet. Now let me tell you, children, we know the very well that. So it is made up of the soft iron, right? Yes. Soft iron. Children, as long as the current is passing, then only what will happen is it behaves like a magnet. This hammer is there, it's an iron one. Okay. Now children, let us see that this key is on. The moment key is on, what will happen? Current will pass through this. So circuit is connected. So let me tell you, circuit is connected. Then what will happen? Current is passing through this also. So it behaves like a magnet. Children, the moment it behaves like a magnet, and this hammer is attracted towards this electromagnet. Then what will happen? This hammer will hit a gong. Just take a situation where yes, it is hitting the gong. Means it moves forward. The moment when it moves forward, here what will happen here? It will get disconnected. Try to understand. It will become like this. It will become like this. It gets disconnected. So once it will get disconnected, what will happen? Circuit got broken. No more current through the electromagnet. Then what will happen? It loses its magnetic properties. It behaves like a normal magnet. As it is a normal magnet, do you think that still this hammer is attracted towards this soft iron? No, it won't attract it. Then what will happen? Due to this spring action, what will happen? This hammer again comes back to its original position. The moment when it comes back to its original position, again it gets connected. The moment it get connected, again current is flowing, it will attract, again it will hit. So the moment when this hammer will go forward, it is hitting, sound is coming here, disconnected. Due to the spring action, it comes back. The moment when it comes back, again connected, again it will go forward. So this is how repeatedly happen. This is how it's as long as you press it, repeatedly it happens. So based on this, what are the questions can be expected, children? First of all, so write the applications of electromagnets. You can write electric bell. In electric bell, we can use U-shaped electromagnet. These are made up of the soft iron only. What would happen if it is made up of the steel, children? So this hammer will like this, tung, that's it. Whether you switch on or switch out, do you think it will come back? No. Why? Permanent magnet, right? It will hold it permanently. So that's what we are using a soft iron. And some students may get out, sir, what happens in the place of DC current if I use AC current? So AC current means polarity will be changing. Means here once the south pole, north pole, south pole. But do you think that this change in polarity will show the impact on the attraction? No. So either you can use DC current, AC current. Nothing makes different. Is it clear, children? Fine. So this is, so I think it might be around 1 hour, 1 hour 50 minutes. But children, again I'm telling you, maximum we covered the point. Maximum we covered. I think almost 90%, yes, you are. So 100% I cannot give your students because you have to read the textbook also, right? Okay, so children, concepts are very important. So when you consider the 9th class children, especially sound, current, electricity, magnetism will carry the maximum weightage in your annual examinations. Okay, na? So children, I am telling you again, once again, you have to read the textbook. Children, the moment when you start watching this video, my humble request, just be ready with a pen and paper in the sense notebook. Try to note out the important points, so that what will happen, you will have a short notes which is used to revise just before the exam. Okay, children? So again I'm telling you, read the textbook, watch the video, gain the knowledge, write the exam well, get the good marks, make your parents happy and proud, children. Okay, thank you so much, all the very best.